quantum computers usually get chilled to minus 273 degrees. QUBT goes the opposite way, using light, at room temperature. If real, it's a game changer. The only question, is it real? The company is Quantum Computing Incorporated, trading on NASDAQ as QUBT. Born from a 2018 reverse merger, headquartered in Hoboken, New Jersey, with its own photonic chip foundry in Tempe, Arizona. The CEO is Yuping Huang, a Stevens Institute professor who actually invented the underlying photonics. Its products span Dirac, an optimization-focused quantum computer, plus quantum random number generators, quantum security, and photonic sensors. It pitches itself not as one quantum play, but as everything you can do with light. So what do they actually do? The biggest enemy of a quantum computer is noise. That's why superconducting machines freeze qubits and ion machines trap them with vacuum and lasers. QUBT bets that using particles of light lets you hold a quantum state at room temperature. Stranger still, it claims to treat noise not as an enemy to eliminate but as a resource for computation. Two things must be precise, though. First, room temperature doesn't equal universal quantum advantage. Dirac is an optimization-only machine. Second, while the other three fight over technology and competition, QUBT has to clear an earlier gate. Are its contracts, its foundry, and its revenue actually real? So what's the moat? Three things. First, room temperature, low-power photonics, in principle no costly cryocooler needed, which, if true, makes it the only one of the four quantum names to escape extreme environments. Second, its own thin-film lithium niobate chip foundry in Arizona, essentially Rigetti's in-house fab strategy moved into light, aimed at telecom and sensing markets too. Third, a multi-photonic platform spanning computing, security, and sensing. But honestly, all three are claimed moats. There's no proof yet that room temperature leads to real quantum advantage, and no track record of the foundry running at scale. Until verified, it's the most alluring sounding, and the weakest, moat of the group. The positive signals come down to three. First, room temperature and low power. If real, it sidesteps the single biggest cost and scaling barrier in quantum, the cryogenic fridge, entirely. That's the promise of quantum on a desk, quantum you plug into a data center. Second, the in-house foundry and multi-platform play. Without waiting for quantum advantage, it can diversify revenue through products you can sell today, quantum random numbers, security, sensors. Third, the potential reward is the largest of the four quantum names. Because it bypasses the biggest barrier, the upside the moment room temperature quantum is proven is asymmetrically huge. On the other side, the warning signals outnumber the good ones. First, verification risk, a dimension the other three never faced. Short seller reports have taken direct aim at the size of its NASA contracts, whether the foundry actually runs, related party transactions, and the technical claims themselves. Second, revenue under $1 million a year while the valuation runs thousands of times sales, the most extreme bubble zone of the four. Third, academic scrutiny hasn't settled whether entropy quantum computing is truly mainstream quantum or just optical analog optimization. Fourth, with revenue too thin to support it, the company keeps issuing stock to refill cash, and that dilution never stops. And don't forget, it's an ultra-high beta stock that swings tens of % on a single headline. In one line, QUBT is the most speculative bet of the four quantum names, the largest potential reward and the deepest verification risk at once. Because if room temperature photonics is real, it bypasses quantum's biggest cost barrier entirely. But this company's first question isn't technology or competition, it's whether the promise is real. Revenue under $1 million a year, valuation thousands of times sales, and that's exactly where the short seller reports aimed. So the verdict is neither buy nor believe, it's watch, understand the substance, and watch the verification signals. Next episode, we examine the downside scenarios where QUBT could falter, starting with verification failure. Tap the cards on screen for the next one.